guys, I'm going to do a quick review of what domain and range are, and actually ways to look for continuity a little bit, as well as two different ways to talk about domain and range. So first off, we're going to be using this graph right here in order to really look at all the different domains and ranges that we can find. So one thing to know is that a function is continuous, technically, if for every single x you have a y. So what that means is that there's really only one value that's completely excluded from the domain in this case. If we're following along here, we have a y for every single x value until we get to this point right here. So here we have a straight hole in our values. So when x equals 1, we have no y value. But if we keep on going right here, oh, we have a hole and we jump, but notice how at x equals 2, we actually have a y value of 3. So we're good to go for this one. If we're moving over to x equals 3 now, notice how even though there's a hole in the function, we have another value that's defined as a point. So when x equals 3 now, our y isn't going to follow our equation to be 5, but rather it's going to jump up to 7. Okay? So we know that that in our domain, or our list of x values, there's no y value equal to 1. Okay? So just to review, the domain is going to be the set of x values where the function exists. So for this example, we know that it's all real numbers except for x equals 1. I'm going to dip this down just a little bit. So now our range, on the other hand, is the set of y values where the function exists. So in this example, if we look in here, we have y values for every single x value. We have some y's, we have y's, but notice how our function kind of bottoms out right here at y equals 1. So we know that our range is going to be every value, or all real numbers greater than or equal to 1, or y is greater than or equal to 1 here. Okay, so there's two different ways we can talk about this stuff, in either interval notation or set notation. I've done a little bit of interval notation, so I'm going to just quickly go over that. But the thing to realize is that these are just two different ways of talking about the same exact thing. So in interval notation, we can fully spell it out. We are trying to figure out, okay, where do our x's exist? So our domain, capital D, well, this thing starts at an x value of 0. So we can start with an open bracket. This means begins. And we know it begins at an x value of 0. Well, we just said that when x equals 1, there's no y, so we can't include that in our domain. So what we do is close it with a parentheses. This means up until. Finally, we're going to use this fancy notation u. And so this is kind of a thing that comes from set theory. This means and, or you're combining two domains. So if you want to talk about two different regions at the same time, you use this right here. So this is code for and. And so now we're talking about the right side now. It squeezes up towards the left side or the right side. So we'd say that it is up until 1, but then it goes all the way out into infinity. And so just good notation is a parentheses for this. If it was a definite number, we would close it with another bracket, but this thing goes, because infinity technically isn't a number, we can just say it goes towards infinity, not to infinity. So that's one way of talking about the domain. In terms of our range, well, we start at 1, so we're going to open up the bracket. We're going to start with an opening bracket, start at 1, and it's going off forever. Even though this thing is leveling out, this function is leveling out, it's always going to be slightly going upwards as our x goes towards infinity. So our y is actually going to be approaching infinity, or with that open bracket. So this is a special one, approaches infinity. Okay, so interval notation, kind of familiar. If not, then we are pretty familiar with it. You can use this, you'll see it everywhere. Another type of notation that you might see, and you definitely will see if you have any sort of future in STEM, in physics, in mathematics, anything like that, what you will see in your classes is what's called set notation. So set notation shows it in curly brackets, and I'm going to write down one way to show this. There's actually 2 ways to show the domain, and then we're going to walk step by step and say what each part of this means. So the domain is equal to the set of x values where x is greater than 0, greater than or equal to 0, and x is not equal to 1. So this translates to the set of x values where x is greater than or equal to 0 and x does not equal 1. So another way we could show this domain is, again, the set of x values, but now we're going to constrain it. The set of x values between 0 and 1, or x is greater than 1. Okay? So both of these would hold okay for the domain. The range is a little more straightforward here. It's saying the set of y values where y is greater than or equal to 1. So the set of y values is greater than or equal to 1. And that's all there is to it. Okay? So it's just a matter of getting used to this notation. You'll see it around. You'll probably see it in the future as we're going through some individual work and some sets and some group work even. So just keeping in mind where this is coming from will be very helpful for you.